So welcome to SAKALAVIDYA YouTube classes. So welcome to the JEE mains and advanced classes. It may be useful for EAMCET and different competitive entrance examination also. So it is targeted to 2023 and 2024 classes. Okay. Now we have been discussing logarithm chapter. In the previous case, we have discussed some part of the concepts. Now the same other concepts will be continued in this session, and also the problems will be discussed. So now let us move to the next concept. Next concept we need to discuss, right? So all of you look at the screen. So let me discuss one by one here. Let me discuss one by one. So now we have been discussing logarithmic inequalities. They are very, very important. Here first one is C, when a greater than 1 and x greater than 1 and x less than a. So this is the first point. So let's have a clear discussion about this one. So Purushottam, welcome. A greater than 1, x greater than 1, x less than a. If you apply logarithm to this one, to the base a, what happens? So that means that implies when a greater than 1, when x greater than 1, x is less than a, then if you apply the logarithm, log x to the base a will be obviously less than 1, and also it should not be actually it must be, if x greater than 0, a greater than 0, log x to the base a will be obviously you will be getting positive value, log x to the base a greater than 0. If you join two inequations, you will be getting like this, 0 less than log x to the base a less than 1 you will be getting. Okay, Mastan, welcome. Right, next second one. So let's have a discussion second one. Second, see, when a greater than 1, that means base is greater than 1, so number is also greater than 1, x greater than a. Obviously, see, if you apply the logarithm, log x to the base a will be greater than 1. Clear? So let us move to the third concept. So what is the third concept? Suppose base is a decimal one. It lies between 0 and 1. Decimal part. Okay, Bhavana, welcome. And also even 0 less than x, x less than 1, number also decimal part, and also x less than a. Obviously, my dear students, you remember the log x to the base a, here as a lies between 0 to 1, symbol reverses, greater than or equal to 1. So fourth point, 0 less than a less than 1, and 0 less than x, x less than 1, x greater than a. So what happens now? Here first of all, if you apply the logarithm, log x to the base a less than 1, symbol reverses, but log x to the base a is positive, will be getting. X and a will have the same interval. So that's why 0 less than log x to the base a less than 1. So these are the inequalities. So we can apply while solving the problems. Now let us move to next concept. Okay, let us move to the next concept. So that is actually we are going to discuss types of logarithms. How many types of logarithms are there? Okay, do you know? Do you have any idea about types of logarithms? See, types of logarithms. So there are two types of logarithms. Types of logarithms. So logarithms defined to the base 10 are called common logarithms or Briggs logarithms, because common logarithms were introduced by the great mathematician Briggs. So by his name, it has named as Briggs logarithms. So that means generally it is denoted by log something, log x to the base 10, or it may be written as log x also. Okay. So now the logarithms defined to the base e are called natural logarithms or Napier logarithms. Generally we write this is log x to the base e, or shortly we can write ln x. Ln x means actually here logarithm of x to the base e. So there are two types of logarithms. So that means we have the logarithms is common logarithms, common logarithms, common logarithms. So here base is 10. Base is 10. So this also called common logarithms, also called Briggs logarithms. Briggs logarithms. Okay, next one is natural logarithms. Natural logarithms. Natural logarithms. So natural logarithms were actually invented by the Napier mathematician. Napier's logarithms. Here base is E. Base is E. Here actually we denote like this. Log x to the base 10, or simply we can write log x. So this we can write log x to the base E, or we can write ln x. Notation will be like this. So these are the types of the logarithms we need to discuss. Right, next. So more discussion. We shall have the more discussion later. Right. Yes, see, we are going to establish the relationship between common logarithm and natural logarithm here. Okay, let's have a discussion. See, suppose here, so you remember log 10 to the base E value is approximately equal to 2.3023, or approximately you can write 2.3. So whenever, if you want to make use of this log 10 to the base E, just consider 2.303 or 2.3. So next point, yes, first point in this one we can discuss log e to the base 10. How to find out log e to the base? Logarithm of e to the base 10 we need to find out. That is equal to, we can write like this, 1 upon log 10 to the base e. So we know that log 10 base e is 2.303. So that means 1 divided by, you will be getting 1.303. This will be approximately, you will be getting 0.43. It's approximately equal to 0.43. So that means log e to the base 10 is equal to 0.43. So for example, see, if you want to find out, so logarithm of n to the base 10, n is any number, logarithm of n to the base 10. So this, my dear students, we can write like this. So log n to the base e, using base rule, we can write log e to the base 10. So we know this property. For example, log a to the base c into log c to the base b is equal to nothing but log a to the base b. Change of base rule. So already see, the log e to the base 10 is nothing but 0.43. So here log e to the base 10 is replaced by 0.43. So this we can write 0.43 multiplied with log n to the base e. So my dear students, so with the help of this one, we are able to convert the common logarithm into the natural logarithm using this relation. So but actually easily we can find out common logarithm easily can be calculated using the logarithmic tables. So now with the help of this is the relation between common logarithm and also this is natural logarithm. I hope it's very clear to you. And some more discussion points we have that we are going to discuss one by one. Right. So we shall have a clear discussion regarding common logarithms also. See, one by one let me discuss. See, common logarithm is sum of two parts. Common logarithm means base 10. For example, you consider log x to the base 10, it is consisting of the two terms, sum of two terms, that is actually integer part plus fractional part you will be having. So this part is called actually characteristic. Plus this second part is called mantissa. That means common logarithm is a sum of integral part plus decimal part. Integral part is called characteristic, whereas this fractional part is called mantissa. See here, same thing itself only. So this common logarithm is equal to integral part plus decimal part. This integral part is called characteristic, whereas decimal part is mantissa. So the characteristic is actually, characteristic may be either positive or negative, but mantissa is always positive, and it cannot be negative. You remember one thing, mantissa is always positive. So here you see, characteristic is the positive or negative integral powers of 10. Mantissa is a non-negative decimal fraction. The characteristic of a common logarithm of a number greater than unity and with only one digit in its integral part is 0. So that means, for example, see, if you want to find out logarithm of 5 to the base 10, easily we can write the characteristic, because it contains only one digit, 1 minus 1, it's 0 plus something. Here decimal part you will be getting, fractional part you will be getting. So this part, with the help of logarithmic table, we can find out. So for example, logarithm of some 35 to the base 10 is there. How many digits are there? 2 digits. Its characteristic is 1 plus fractional part you will be getting. Suppose 3 digit number. So 375 to the base 10. So its characteristic is 2. So it's very clear. You can observe that there is a pattern. For example, if there are n numbers in a given number, then its characteristic is, you will be getting obviously n minus 1 itself only. So that means, you see, the characteristic of a logarithm of a number n with n digits, then its integral part. The integral part is nothing but characteristic, that is n minus 1. So for example, sometimes number may be negative, like this, logarithm of 0.5 to the base 10. Its characteristic is negative, that you will be getting negative 1 plus fractional part, negative 1. So for example, 0.05 is there, its characteristic is negative 2. 0.005 is there, its characteristic is minus 3. So that means, here see, the characteristic of a common logarithm of a decimal fraction n with n zeros immediately following the decimal point. Immediately following decimal point, n zeros are there. Here 2 zeros means minus 3, 1 zero is minus 2, no zero means actually minus 1. So that means, for example, here minus characteristic will be minus of n plus 1. You remember like this. So when the number is a decimal fraction, then you will be getting the negative characteristic. The mantissa is the same for the logarithm of all numbers which have the same significant figures. So that means, actually see, 0.5, 5, 0.05, 0.05 have the different characteristics, but mantissa will be same. They are called significant figures. So that means you can write like this. If two numbers n and m are so related that n is equal to m multiplied by 10 to the power of p, because here n and m have the same significant figures, so these m and n will have the same mantissa. This mantissa will be obtained from the logarithmic tables. If you want, you can refer the logarithmic tables also. Right. So next, one more beautiful concept we need to discuss. This is very, very important while solving the problems. Right. So this is the relationship between the geometric progression and arithmetic progression with the help of the logarithms. See, suppose a comma b comma c are in geometric progression. Right? Geometric progression, and x greater than 0, x is positive. For example, if you apply the logarithm to the each and every term of the logarithmic geometric progression, which is a comma b comma c, then what do we get? See, we get like this: log a to the base x, log b to the base x, comma log c to the base x. So obviously are in arithmetic progression. That means AP, arithmetic progression. So write the reciprocals. reciprocals, that means 1 upon log a to the base x, comma 1 upon log b to the base x, comma 1 upon log c to the base x. So these we can write as like this: log a, log x to the base a, comma log b to the base x, log x to the base b, and log x to the base c, or in harmonic progression. This is actually AP, so this is GP, geometric progression. The harmonic progression, there is HP. I hope it's very clear to you. See statements now. If A comma B comma C are in geometric progression and x greater than 0, log A to the base x, log B to the base x, log C to the base x are in arithmetic progression, whereas log x to the base A, log x to the base B, log x to the base C are in harmonic progression. This is very, very important. So while solving the problems, right. Right. Next concept we need to discuss. Okay, all of you look at the screen. I hope it is visible to you. Very clear visibility is there, right? So this is also very, very important. The least value or minimum value of log a to the base b plus log b to the base b is 2, where log a to the base b is greater than 0, positive. So my dear students, let's have a discussion here. We have, suppose let x is equal to log a to the base b and y is equal to log b to the base a. For our convenience, log b to the base a we can write 1 upon log a to the base b. Clear? So already what is given actually here? Log a to the base b is greater than 0. That implies x is positive. X greater than 0, even 1 by x, obviously y is also greater than 0. So Dhoni, welcome. Right. Suppose since x and y, x greater than 0, y greater than 0. So let us write arithmetic mean of these two. Arithmetic mean of these two numbers, that is x plus y by 2. Am I correct? And geometric mean right, that is under root of x into y. So we have the relationship between arithmetic mean and geometric mean. So we know that arithmetic mean is greater than or equal to geometric mean. Am I correct now? Arithmetic mean is greater than or equal to geometric mean. So that we can write here x plus y by 2 is greater than or equal to root xy. By cross multiplication we will get x plus y greater than or equal to 2 root of xy. So let us substitute x for log a to the base b, y for log b to the base a, or this value you can substitute. Then see what do we get now here. So therefore x is being replaced by log a to the base b, plus whereas y is being replaced by log b to the base a. So greater than or equal to 2 times, again x is being replaced by log a to the base b and multiplied with y is replaced by 1 upon log a to the base b. So now what happens? Log a to the base b, log a to the base b cancels out. So we have this is greater than or equal to 2 root of 1, that is 2. So always you remember log a to the base b plus log b to the base a is always greater than or equal to 2. Equal to 2 or greater than or equal to 2. That means minimum value is 2. So therefore we conclude that the minimum of log a to the base b plus log b to the base a is equal to 2. So that's why least value or minimum value is 2. I hope it's very clear to you. Let us move to yet another concepts now. These are very, very important concepts. Right. See, don't worry, I will write once again for your clarity. See, here important series to be discussed. Log of 1 plus x. This is to the base e only. So this can be expressed as a series in terms of x. That is called power series. That is x minus x square by 2 plus x cube by 3 minus x to the power of 4 by 4 plus x to the power of 5 by 5 and minus and so on. You will be getting infinite series, and also here minus 1 less than x, x less than or equal to 1, this condition. So my dear students, for example, here one deduction we can make it now. Put x is equal to 1 both sides. What do you get now here? Therefore you will be getting log of 1 plus 1 is 2. Log 2 base e is equal to 1 minus 1 upon 2 plus 1 upon 3 minus 1 upon 4. This is oscillating series actually, minus and so on infinity. It will be useful for the problems. Please remember, please note down in the notes. Otherwise, take a screenshot of this one. See, similarly, the second one we can remember, that is second one, log of 1 minus x. It will be very interesting, that is to the base e. This is negative of x plus x square by 2 plus x cube by 3 plus x to the power of 4 by 4 plus so on infinity. So now if you subtract 1 second from 1, then you get this series, that is the third series, logarithm of 1 plus x by 1 minus x to the base e is equal to 2 times of x plus x cube by 3 plus x to the power of 5 by 5 and plus so on infinity. Here condition is also actually minus 1 less than or equal to x, x less than 1. Here condition is mod x must be less than. So these conditions are very, very important. So these series are valid only providing satisfying the appropriate conditions, this condition and this condition and this condition. So all of you note down this one. Now let us move to the next concept. Okay, now let us move to next concept. Right. See, I hope it's visible to you. See, what is the statement means? If a comma b are relatively prime, so that means GCD or SCF of a comma b is equal to 1. So then log a to the base b is irrational. Sometimes it may be rational, sometimes it may be irrational. So examples, log 2 base 3 is irrational, log 5 to the base 3 irrational, and something log 2 base 10 is also irrational. Right, they are all irrationals. So if you want to give the proof, simple proof also you can give it, no problem. Right. So let us move to yet another concept now. Let us move to, right. So let us start the problems now. So problem number 1 now we are going to discuss. Right. So this is the question. This is the question. First let me read the question carefully. So what is given actually here? See, log 3 to the base a equals to 2. If log 3 to the base a is equal to 2, log 8 to the base b is equal to 3, then we are asked to find log b to the base a. Log b to the base a. So option A, log 2 to the base, this is 5, log 3 to the base 2, log 4 to the base 3, log 3 to the base 5. So we need to find out. So that means first of all, so what kind of strategy we need to follow here? First consider log 3 to the base a is equal to 2. This is a logarithmic form. Let us write exponential form. So that means you can write here a square is equal to 3. So this we can write a is equal to 3 to the power of 1 upon 2 or root 3 we can write it. A in terms of 3 we have written. In the similar lines, log 8 to the base 3 is equal to, we can write 3, that is b cube is equal to, so b cube is equal to 8. So this we can write b cube is equal to 2 cube. So now comparing on both sides we get b is equal to 2. So our aim is to determine log b to the base a value, log b to the base a in terms of 2 and 3. So log b means b is replaced by 2, that is log 2, base a, that is 3 to the power of 1 upon 2. So my dear students, in logarithms already we have discussed. So this is log x to the power of n to the base a is equal to n times log x to the base a. This is power rule. So with the help of power rule, otherwise we have one more formula also. So that is log, for example, a to the power of alpha to the base b to the power of beta. This we can write alpha by beta log a to the base b. So this is the relevant in this case. Am I correct now? So with the help of this can be written 2 power 1, 1 upon 1 by 2, that is 2 times log 2 to the base 3. Again, to take the power back, this we can write log 2 square to the base 4. 2 square, base 3. 2 square is 4. So log 4 to the base 3 is answer. So C is the right option. I hope it's very clear to you. This question is clear to you, right? Let us move to add another question now. Right. Second question. See, my dear students, if a comma b comma c are distinct positive numbers, different from 1, such that sigma log a, this is actually sigma log a to the base b, sigma log a to the base b, right? 1 minute. So let me clarify this question now. Next, log a to the base c minus log a to the base a is equal to 0. Then we need to find out the ABC value, the value of ABC. How could you find out? So my dear students, first of all, let us simplify this bracket value. So now consider here given expression is equal to sigma this log a to the base b, that we can write log a by log b. Am I correct? And multiplied with this log a to the base c, we can write log a by log c. Minus log a to the base a, we can write, that is 1 only, log a by log a, write down. This is given expression is equal to how much? 0 given. So now let us simplify it. So this can be simplified. You put sigma as it is. Here obviously the LCM will be log a, log b, log c. So now log B log C cancel. Log A into log A into log A, that will be log A whole cube. Am I correct? Minus log A cancel. Log A into log B into log C. Log A into log B into log C. So is equal to 0. Cross multiply with this one. So then you will be getting like this. Sigma log A whole cube minus log A log B log C, okay, equal to 0 multiplied with log A log B log C, will be getting 0. So now let us introduce the variables like this. Let us say log A is equal to x, log B is equal to y, log C is equal to z. Then what do we get now? So this becomes like this. Sigma x cube minus 3xyz. Sorry, xyz. Using symmetric property, if you just expand the sigma, you will be getting like this. X cube plus y cube plus z cube minus xyz minus xyz minus xyz. 3 times. So minus 3xyz is equal to 0. From basic algebra, as x cube plus y cube plus z cube minus 3xyz is equal to 0, that implies you will be getting x plus y plus z is equal to 0. So let us replace what is x. X is equal to log A, y is equal to log B, z is equal to log C. So we get log A plus log B plus log C. So using product rule, this log A plus log B plus log C can be expressed as a single log. That is logarithm of ABC. This 1 we can write logarithm of 1 to any base. So ABC must be equal to 1. So our answer is 1. ABC is equal to 1. So that means right, C is the right option. C is the right option. C is the right option. So let us move to next third question now. Third question. Right, third question. Right. So this is the third question. So the value of log 2 base 4, log 2 base 4 minus log 2 base 8 plus log 2 base 16 and minus and so on dash dash infinity is equal to. So this value we need to find out. See how to find out. So my dear students, now the given expression we can write is equal to log 2 base 4 we can write 1 upon log 4 to the base 2, clear, minus log 2 to the base 8 we can write 1 upon log 8 to the base 2, plus this log 2 to the base 16 we can write 1 upon log 16 to the base 2, and minus and so on infinity. Right, let us try to find out all these values. My dear students, you see, this is 2 square, so 2 into log 2 base 2, it will be 2. This is 2 cube, 2 power 4. So that directly we can write 1 upon 2 minus this will be 1 upon 3 plus 1 upon 4 and so on minus dash dash infinity. So already we had a discussion. See, we know that log 2 value. What is log 2 base E is equal to? We have 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus dash dash infinity. Am I correct now? So log 2 value. That means we are able to write in terms of log 2 value. So that means this can be rewritten as, so 1 minus of, sorry, minus 1 of, this is okay, 1 right out, 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 and plus dash dash infinity. See, my dear students, if you just remove the brackets, you will be getting the above same step itself. So now this is being replaced by log 2 base E. So this equals to 1 minus log 2 base E. It's a logarithmic series problem. So 1 minus log 2 base e means D is the right option. D is the right option. So third problem has been completed. Let us move to fourth problem now. So let us move to fourth problem. Right, fourth problem. Right, you see the fourth problem now. This is the sum of the series, that is 1 upon log 4 to the base 2 plus next is log 4, sorry, 1 minute, let me write, plus 1 upon log 4 to the base 4 so 1 minute, I check the question, right. Next one is plus 1 upon log 4 to the base 8, log 4 to the base 8 plus so on 1 upon log 4 to the base 2 power n. So this value we need to find out. Right. How shall we proceed this question? This we can write log 2 to the base 4 plus log 4 to the base 4. Right. So next what do we write? Right. Plus this we can write log 8 to the base 4 plus so on, this we can write log 2 power n to the base 4 we can write. So as the same basis, it can be expressed as a single logarithm, that is log of 2 into the 4 we can write 2 square, this is 2 power 1 into 8 can be written 2 cube and so on into, that is 2 raised to n to the base 4. As bases are equal, the powers are added. So this we can write logarithm of 2 to the power of 1 plus 2 plus 3 plus so on dash dash plus n to the base 4 we can write it. Clear? So now what is the value of 1 plus 2 plus 3 plus dash dash n? This is nothing but sum of the first n natural numbers. So this is nothing but n times n plus 1 by 2. Am I correct? So, but we can write logarithm of 2 to the power of n times n plus 1 by 2. It's a power. This 4 we can write 2 square. So this is equal to n times n plus 1 by 2 by this 2 into log 2 base 2, that is 1. So this is equal to n times n plus 1 by 4 you will be getting 2 into 2 4. So D is the right option. D is the right option. Otherwise, by substituting n is equal to 1 or n is equal to 2, options can be verified. Verification method also can be entertained regarding this problem. Right. So let us move to yet another problem. Yet another problem. Right. So sixth problem. Let's have a discussion on sixth problem. See, this is based on concept only. Log 7 to the base 2. Log 7 to the base 2 is an integer, a rational number, an irrational number, a prime number. See, here already we have, so one concept we have discussed. If a comma b are relatively prime, then log a to the base b is an irrational number. So now check these two numbers, 7 and 2. So that means therefore log 7 to the base 2 is an irrational number. Is an irrational number. Since A comma B are relatively prime. A comma B are relatively prime. So an irrational number is the right answer. An irrational number is the right answer. So next question. Right. So all of you just look at the screen. The value of log 3 to the base 20, log 3 to the base 20 lies in. So that means which interval does log 3 to the base 20 belong? That we need to find out. So now you see the 20, for example, you find 3 square, 3 square is equal to 9. You find 3 cube, 3 cube is equal to 27. That means the value this 20 obviously lies between 9 and 27. So we can establish an inequality here like this. 9 less than 20, 20 less than 27 we can write. Am I correct? So next after that what shall we do now here? This 9 we can write express as 3 square less than 20 less than 27 can be written 3 cube. Apply logarithm log to the base 3 to the base 3. So on applying logarithm to the base 3 you get like this, log of 3 square to the base 3. Since base 3 symbol will not reverse, same symbol retains. So this is log 20 to the base 3 less than log of 3 cube to the base 3. So we know that logarithm of x to the power of n to the base a is equal to n times log x to the base a using power rule. So this can be written 2 times log 3 base 3 is 1, that is log 20 to the base 3 less than 3. That means log 20 to the base 3 lies between 2 comma 3. But we are asked log 3 to the base 20. That means write reciprocals. Write reciprocals. That's called writing reciprocals. So writing reciprocals means this can be written 1 upon 2 symbol reverses greater than 1 upon log 20 to the base 3 greater than 1 by 3. In reverse order I down 1 by 3 less than this 1 by log 20 base 3 we can write log 3 to the base 20 less than 1 by 2. So my dear students, log 3 base 20 lies between 1 by 3 comma 1 by 2. Therefore, we can write log 3 to the base 20 belongs to which interval? Open 1 by 3 comma open 1 by 2. This is closed. So 1 by 3 comma 1 by 2. So that means B is the right option. B is the right option. I hope it's very clear to you. Very clear to you. So you can chart and you can chart your answers also, no problem. Okay, let us move to yet another question. This is also very interesting question. Right. Right. Here see, log 3 to the base 10 is equal to 0.4771. Then the number of digits in 3 to the power of 40. The number of digits in the resulting number 3 to the power of 40. How many number of digits does the number 3 to the power of 40 contain? That we need to find out. What is given here? Log 3 to the base 10. This will be given in the examination, don't worry. So you need not refer the logarithmic tables. From logarithmic tables also you can find out. So next, that means how to find out means you can say let the number be n. So n is equal to 3 to the power of 40. Apply logarithm on both sides to the base 10. We can write log n to the base 10 is equal to logarithm of 3 to the power of 40 to the base 10. So then using this power rule, 40 times log 3 to the base 10. So that means 40 times log 3 to the base 10 means the value has been given. So that means log 3 to the base 10 is being replaced by 0.4771. So let us multiply. So first remove the decimals, 4771 multiply with 40. So what do you get? 0, 0, 0, 0. 4, 4, 1 ja 4. So very good, very good. 66. Ramya Sai. Okay, thank you. 4 1 ja 4. 4 7 ja 28. 4 7 ja 28 plus 2 30. 4 4 ja 16, 19 you will be getting. So that is 190840. How many points we need to write here? 1, 2, 3, 4 points. You put 4 points here. 1, 2, 3, 4 points. So this equal to 19.084. So logarithm of natural logarithm is consisting of the two parts, integer part plus decimal part 0.084. So this is called characteristic. This is called actually this is called mantissa. So now the number of digits is equal to characteristic minus 1. That means 19 minus 1. So 19 minus 1 is equal to, sorry. This is characteristic plus 1, you need to write it. 19 plus 1, that is equal to 20. So number of digits is 20. This is the right answer. Okay, let us move to today's last question. Tomorrow we shall discuss remaining problems, or 2 more questions also we shall have a discussion. Okay, next let us move to this question now. All of you go through this question. See what is given actually here. If x greater than 1, y greater than 1, z greater than 1 are 3 numbers in geometric progression, then 1 upon 1 plus log x to the base e, comma 1 upon 1 plus log y to the base e, comma 1 upon 1 plus log z to the base e are in which progression? Arithmetic progression, harmonic progression, geometric progression, or arithmetic geometric progression. Because actually these are the types of the progressions. So first of all, what is given? Let us write it now here. X is positive. All these are 3 positive real numbers. So x comma y comma z are in geometric progression. First write up. So if you apply the logarithm on both sides to the base e, that means log x to the base e, comma log y to the base e, comma log z to the base e, obviously are in arithmetic progression. If you apply the logarithm of GP is equal to AP. So now if you add a constant term, non-zero constant term, or even constant term, each term of a arithmetic progression, the resulting series also in arithmetic progression. I will tell you. For example, A comma B comma C are in AP, even A plus or minus K, comma B plus or minus K, comma C plus or minus K are also resulting series, new series in arithmetic progression. That means adding 1. So that implies 1 plus this we can write ln x. So this is 1 plus ln y, comma this is a notation 1 plus ln z are also in arithmetic progression. So reciprocals of the terms of arithmetic progression obviously in harmonic progression. So therefore reciprocals write up 1 upon 1 plus ln x. So 1 upon 1 plus ln y, comma 1 upon 1 plus ln z obviously are in harmonic progression. So our answer is harmonic progression. So B is the right option. B is the right option. Are you there, all of you? Purushottam, Ramyasri, Dhoni, you need to, after completion of the session, you need to comments. So then based on that, our classes will be conducted, next classes. So, but moreover, this time I will be discussing all level of problems. Level 1, level 2, level 3, level 4, level 5, level 6 also. It will be continued till the end of the examination up to 2024. Right, let us move to next question. Right. See the question. This question is connected to the logarithms, connected to the quadratic equations. If the roots of the equation, that is x square minus 4x minus log a to the base 2 is equal to 0 are real, this is very important. This is the stem of the problem. So then a greater than or equal to 1 by 2, a less than or equal to 1 by 8, a greater than or equal to 1 upon 16, a greater than 1 upon 6. So just roots of a quadratic equations are real. That means nature of the roots are here, roots are real. That means this can be obtained, you know, that using discriminant of a quadratic equation. That means we need to find out the discriminant. So for that purpose, we need to compare this one with ax square plus bx plus c is equal to 0. So we get, my dear students, a is equal to coefficient of x square 1, b is equal to coefficient of x, that is negative 4, and c is equal to negative log a to the base 2. Clear? So since roots are real, since roots are real, discriminant is d is greater than or equal to 0. D stands for b square minus 4ac. So b square minus 4ac greater than or equal to 0. Let us substitute the respective values. So b square means minus 4 square, 16 minus 4 times a means 1, c means minus log a to the base 2 greater than or equal to 0. So now you will be getting 16, this is plus 4 log a to the base 2 greater than or equal to 0. So now we need to solve. This is 4 times log a to the base 2 greater than or equal to negative 16. So log a to the base 2 is greater than or equal to, divide by 4 means minus 4. So this is here actually, so remember this 2 is positive. 2 is positive means when you change into the exponential form, the inequality symbol does not change. So that means a greater than or equal to 2 to the power of minus 4. So that means this equal to 1 upon 2 to the power of 4. 2 to the power of 4 is nothing but 16. So therefore you will be getting this inequation, that is nothing but a greater than or equal to 1 upon 16. This inequality you will be getting. A must be greater than or equal to 1 by 16 so that this quadratic equation has real roots, possess real roots. So this C option is the right option. So thank you for watching. See you. And tomorrow we shall continue the session.